Hey guys, this is Eddie the Magic Monk. I want to start talking about horizontal translation of trigonometric graphs. So hopefully you guys have understood vertical translation from my previous video, otherwise it's going to be a bit hard for you to understand horizontal translation. So let's start with the normal sine curve, y equals sine x. Let's draw a graph of that. And so you can remember that if we want to draw a graph, we start by using the table of values. So when x is 0, let's work in radians now. So pi over 2, pi, 1.5 pi, and 2 pi. Okay, so what is the sine of x? Alright, so when x is 0, sine 0 is 0. Right, when x is pi over 2, sine pi over 2 is 1. And then back down to 0, to negative 1. And back to 0. Okay, so if you don't understand this table, you really need to have a look at my other tutorials for trigonometry. Okay, so that is the original curve. Right, when x is 0, y is 0. When x is pi over 2, y is 1. So let's get the graph up. Right, so that is the graph there. Now, so that's the x-axis horizontally, and that is the y-axis vertically. So when x is pi, y is 0. When x is 2 pi, y is 0, and so on. And the curve is obviously y equals sine x. That's the curve. So now what I want to achieve is I want to draw another line. Okay, I want to draw another line so that the line is shifted pi over 2 radians to the right. Okay, it's shifted horizontally by pi over 2 radians to the right. So these will now be the key points. These will now be the key points. Alright. So it's shifted 90 degrees to the right. Sorry about my bad drawing. So how do we achieve that? So this is what you do. Okay, so what I'm going to do is I'm going to write another row on my table of values so you can see how we backtrack to get the equation. So this is what we want to end up with. Okay, the y value is going to be when x is 0, y is negative 1. Okay, we're trying to work out the equation, y equals something. We don't know what this is. We're trying to work that out, right? But we know that when x is 0, the new equation, the green line is the one we're trying to find. Okay, when x is 0, y is now negative 1. When x is pi over 2, y is now 0. Right? When x is pi, y is now 1. Right, when x is pi, y is now 1. And when x is 1.5 pi, y is now 0. And when x is 2 pi, y is now negative 1. Okay, so it looks like that. And you can see a bit of a pattern happening, and that is whatever number is here in our third row, it matches the number diagonally to the left upwards from in the second row. So it matches this number. The number 1 here matches this number. The number 0 here matches this number. And the number here, negative 1, matches this number. So what does that mean? Okay, in order to get this number here, what we do is we take away pi over 2 from our original x value. So I'll just show you by doing it. If I go ahead and wrote down x minus pi over 2 to our x value here, so 0 would be 0 minus pi over 2 would be negative pi over 2. Pi over 2 minus pi over 2 is 0. Pi minus pi over 2 will be pi over 2. 1.5 pi minus pi over 2 will be pi. 2 pi minus pi over 2 will be 1.5 pi. So if we minus pi over 2 from our x value first, and then put it in the sine function, okay, so y equals sine of x minus pi over 2. If we do that, if we put this number into the sine function, when x is 0, sine of 0 will be 0. When x is pi over 2, sine of pi over 2 will be 1. Right? When the input is pi, sine of pi will be 0. So this is how we arrive at our new function. So basically, okay, to shift it to the right, we would put into our bracket x minus a number a. Right, this curve will shift the curve sine x to the right by a units. Okay, but the important thing here is to note that this only works when coefficient of x equals 1. So this number in front of x, it has to equal 1. Right? If it equals something else, then I'm going to cover what to do in the next tutorial. So what if you plus a certain number? So y equals sine x plus a. This will shift y equals sine x to the left by a units. Right? Only works when coefficient of x equals 1. Okay, so let's test it out in Desmos to show you that it works. So originally we have y equals sine x. Let's now put in y equals sine bracket x plus 3 pi over 2. Right, so you can see here that originally, minus 3 pi over 2. So you can see here that originally the origin is here, but I have moved it all the way over here. So it has shifted to the right by 3 pi over 2 units. Okay, so originally the dot is here, right? I've shifted it over here, and it's going to go up and then down. It goes up and then down, just like the same shape as the normal sine curve. Now, if I do a minus, y equals sine x, sorry, I did a minus. If I do a plus pi over 2, okay, what happens? I have shifted the curve to the left by pi over 2. So if you plus a number in the bracket, okay, it shifts it to the left. If you minus a number in the bracket, it shifts it to the right by a units. Now, right now, the coefficient of x is equal to 1. In the next video, I'm going to talk about what happens when the coefficient is not 1. Okay, thanks for watching, guys. See you next time.